everybody, and welcome to a new episode of Where Have You Been Lately, brought to you by the Boyertown Museum of Historic Vehicles. And today, this is a really special episode of Where Have You Been Lately.
More special than every other one we've done?
They're all special, but this one's super special.
Okay.
We're on the road today. We're here in Media, Pennsylvania at Cycle Sport. And our friend Harry Havnoonian is going to show us around, and we're looking forward to a behind-the-scenes look here at Cycle Sport.
Yeah, I'm ready to go.
Yeah, we're excited, and if the name Harry Havnoonian or Cycle Sport is familiar to you, which we hope it is, because you've seen another video here on our YouTube channel of Harry's presentation at the museum's annual dinner. If you haven't seen that video, go into our YouTube playlist, check it out, and you're going to learn more about Harry and what he does here. And now we're going to get a different perspective today on what he does here. So why don't we go inside?
Okay.
All right. Hi, Harry.
Hi, Kendra. How you doing?
Good to see you again.
Hey, Dan. Long time no see.
Okay. Yeah.
So this is Cycle Sport. Welcome.
Yeah,
This-
man, you're filled to the brim here, aren't you?
Well, you know, this is the post-COVID Cycle Sport. The pre-COVID Cycle Sport was jammed. We would have 1,200 bikes on hand. There was bikes everywhere.
This
And,
isn't jammed?
Oh, no.
Oh,
far,
wow.
Far from it.
Wow, wow, wow.
I
Wow,
do
what's up
see
here?
some empty spots here.
Yeah, there's actually quite a few. But this is the world we live in now. And,
Yeah.
It'll change. It'll get back to normal.
Now, we drove in today and we came down this road and went around. And you've got all these windows out here. I was astounded by all the bikes lined up in the windows. It looks great from the outside.
So this is a kind of an interesting shop. Originally, this was 3 wooden structures. To go way back.
Okay.
And then what happened was there was a bike boom back in the early 1970s, and another shop wanted the Schwinn franchise. And Schwinn told them, as long as this place is in business, you're never going to get bikes. And then a week later, this place gets firebombed, burns down to the ground. So when they rebuilt the building at the time, because this was one of Schwinn's larger accounts in the country, they offered to design the building. So they stepped in, which is why it has all these windows, because they wanted to break away from what was the traditional bike shop, where you drag your bike through the shop and, you know, it's like dirty and greasy and crowded and messy. So they wanted it so when you came in the front door, sales were this way, service was that way. So you keep your dirty bike away from our clean showroom.
Sure. And then all the windows make it seem lighter and brighter.
Yes, brightened it up.
Yeah.
So that's what that was about.
Oh, cool.
But what we're here for today is we actually manufacture bikes in our basement, high-end race bikes.
Yeah.
And they're all built, you know, one at a time, body measurements, you know, specifically for you.
That is
So
really neat.
if you're ready, we can go down and look at
I
it.
would absolutely
ready.
love to see it. Let's go.
All right, let's walk back through this way. All right, so here's the frame shop.
Wow. They're steel tubing. Wow. So this is where the bikes are made, down here.
Yeah, it's
These machines.
it's a process. So if we were to start from the beginning, you would come in, and we would talk about, you know, bikes that you have owned. Because if our bike is the first good bike you're getting, I would probably recommend getting something else. Well, it's kind of like if your first car is a Porsche 911, you're probably going to kill yourself. Okay. So it's the kind of thing, it's like you work your way up into this category of bike.
Okay, all right.
So we have an interview, we talk about bikes that you've owned, things that you have liked or disliked about them, what you want to do with this new bike, like is there a specific type of racing that you do? And then we take body measurements, we get a sense of how heavy you are, how strong you are, your weight distribution. Because if you have 2 people that are the same exact height and weight, and somebody has like more upper body development, I would design that bike differently than someone that was otherwise.
Wow, I didn't realize all that went into it.
Well, it does. Anything high-end gets very specific.
Okay.
So it's just racing bikes we're talking about?
Well, we can build anything, but that's my passion.
Yeah.
I love building race
And,
bikes.
I am a racing person, interest with cars though, but I can see the little intricacies of having certain specifications because you want it to be the maximum for the rider.
Yes.
And
that's
a
really
big sentence, but I think you.
Well, but that's essentially what it's about.
Yeah.
Because you're getting something that's 100% custom made, so you can dictate every aspect of the bike. Mm-hmm. Not just color, but where do you want fittings welded on? Where do you want your water bottle? Do you like reaching way down? Do you want it to be higher up? It's like you dictate everything.
So let me ask you a question. You mentioned like if a person has more body weight from the waist up than somebody else, what difference would that be in actually making a bike?
So what I would do is I would design the bike so that the top tube, which is this bar here,
Right. Mm-hmm.
I would make that longer
Okay.
and make the stem shorter. So the position is still the same, the distance from the seat to the handlebar.
Mm-hmm.
But what that does is it moves the front wheel out
Okay.
so that you get back to that more ideal weight distribution.
Okay.
Huh.
Typically we shoot for general purposes 55%, 45% body weight. That does change depending on types of racing that you do. Mm-hmm. But for the same kind of event, same size guy, one with a heavier upper body, that's what we would do to accommodate.
Wow.
Yeah, it gets really specific.
Yeah.
After the interview process, what I do is you go back to wherever you came from, and I sit there and I'll actually take notes while it's still fresh in my head. This is the gauge top tube I want to use, this is the diameter, this is an angle, blah, blah, and I write it all down. And then when I get home to my office, that's where I draw all the blueprints, and I draw them all by hand. We actually did have a CAD system, and I did one frame with it, and I probably didn't give it enough of a chance, but the problem is that when I design something, I have to feel connected to it. And on a CAD system, I can't get connected to a final product when I'm going through a computer and a screen. It's like I need to have something like that's tangible that I could actually sit there and draw the line in.
It's like you put a middleman in there.
Yeah, right. It's like a buffer. It's
Yeah.
like something's getting lost, whether it is or not. I in my mind, it is.
Right.
So it is.
Huh.
So I draw them all by hand, and we can go over here and I can show you what one of those looks like.
Ooh, yeah.
So in drawing the blueprint, this takes into account the center-to-center dimension of all the tubes, all the angles between tubes. Mm-hmm. And by drawing it out, I could look at things like trail and rake to make sure that the front end is doing what I'm looking for. Typically, we look for about 2 inches of trail. That gives pretty good stability, but depending on the bike, if you're doing like a track event, like the velodrome, like Trek Slip Down, that type of racing is all really high-speed, quick maneuvers. So you don't want to sit there and steer the bike. So we have a geometry up front here that's very susceptible to leaning. So you basically shift your weight, and by pushing on the seat, the bike will dive.
Okay, it's less of this and more.
And more, right.
All right.
It's more like finesse as opposed to muscle.
It's almost like you're one with the bike then.
Well, yeah, and,
yeah.
and that's really what we try to do.
Yeah.
And that's why we interview, to find out what you're doing, so
Makes
that
sense.
we can do the best to make sure that this matches up with your needs.
Now, sorry, you said 2 inches of trail. What do you mean by that?
So what the trail is, it's how much the axle trails the steering axis.
Okay.
So if you draw a perpendicular line through the axle, that's where the tire contacts the road. So it's this point right down there.
Okay.
And then if you extend the angle that goes, if you follow this angle right here with the amount of rake, which is that line right there. And the difference between that point is 2 inches, roughly.
Okay.
right? The axle trails the head angle.
Okay.
All right.
Now, this is a 1/3 scale drawing, so if you were to multiply that distance by 3, it would be roughly 51 millimeters, which is about 2 inches.
2 inches. Okay.
So, draw the plan. This gives all the dimensions, and then there's little fittings that get welded onto the frame for gear shifting, for cable stops, for water bottles, and all that stuff gets listed on the plan, and any special instructions will get written on here. When the bike is finished, it gets serial numbered, and that serial number gets written on the plan so that years later, and it doesn't happen often, but it happens, you're in an accident, bike gets smashed up, they ship it back to us, we take it apart, we use, we get the serial number, we pull the original plan, and then we can set this jig back up to those exact dimensions.
Okay.
And we can rebuild your bike to exactly what it was.
Wow.
Yeah, so that's pretty involved. So with this plan, we basically start off with raw materials. So we end up getting tubing, unfinished, just a piece of tube. Now it looks normal, like a regular piece of tubing, but all the metal bikes are made with, high-end ones, are made with what's called budded tubing. Can't tell from the outside, but this wall, which is the thickness of the metal, varies as you go down the length of the tube. So when this tube is made, they actually have a die that fits on the outside, and then they have a mandrel that fits inside, and the mandrel is computer controlled, and it opens, they draw it through, which makes a thinner wall. It gets pulled in a little bit, they draw it gets pulled in some more, they draw it. So if you were to actually cut this tube lengthwise, it's 7/10 of a millimeter here, tapering down to 5/10 in the middle. So that's 20 thousandths of an inch.
Wow.
7 hairs, the thickness of a hair, 7 of them. And then it goes back again.
Now, would that be to save weight and you want more strength here than in the middle?
Yeah, and actually that's a good question. All the material that bikes are made from, the metals, are all heat treated, which means they're heat sensitive. So after this tube is made, whatever heat we put into it to make your bike weakens the frame.
Okay.
Right now, this tube has the most strength that it's going to have.
We'll ever have.
Yeah. And once we start welding, it gets diminished. Now, there are some alloys of steel that actually get harder as you weld on them. And that's what these 2 tubes here are. It's air hardening steel, they call it. Real high chromium content. And it actually picks up strength when you weld.
Oh.
And actually, it's pretty interesting. This is made by, or the alloy is owned by Carpenter, which is a Pennsylvania
Yes.
steel company,
Yeah.
right? Yep, and it literally it dictates the entire metal bike industry worldwide. Yeah, they're making money on that one.
Wow.
Yeah,
Right here in PA.
right here in PA. So if it's a real high-end exotic bike, budded tubing, and then we have a whole tubing rack behind you there that has all straight gauge tubing, meaning constant wall thickness. And for that, we use that for real special projects. Like we do BMX bikes, and nobody really makes a budded tube set for a BMX bike, or tandems. Nobody makes budded tubing for tandems. So we'll use straight gauge, and it's not even regular straight gauge tubing. That's all air hardening steel.
Is that because those bikes need to be stronger, or?
Well, it is. There's not the volume of bikes being produced, so the companies don't bother making budded tubes to the dimensions and sizes you need
Okay.
to get those bikes built.
Okay.
With that tube in your hand, okay, since it has different thicknesses of the wall, I guess you specify the length of the tube also, correct?
Yes. This guy's got some good questions.
Yeah, I guess you have to, wouldn't you?
He's done this before. So the company that makes this tube is Vetus, and they put it's not etched, it's like printed on the tube, it's like ink, so that comes off. But this tube, it's not symmetrical, meaning the wall thickness profile from this end of the tube is different than that end. So they put their logo to signify the difference.
Okay.
And then for each tube, we get a blueprint that gives us the budding profile. So depending on what we're doing with this bike, like let's say you're going to race cobblestones. You're going to take it to Belgium. You're going to do cobblestone racing. So for that, the front of your bike is bouncing around a lot. So we would put we'd cut more off the tube at this end so that you have a shorter butt here, so that you have more material at this end, which has to take that shock from hitting cobblestones all day.
Oh, all right.
So that's one of the things,
Okay.
like in terms of if we need a tube this long, one of the things that I do when I design the bike is, you know, do we cut it like this, or do we cut it like that, or do we cut it like this?
Got it.
So it's art and science.
I was going to say, there's a lot of
Yes.
factors
Yes.
to consider here.
Right.
Wow.
Now-
No wonder you need to interview these people
Well,
and get all this
you-
information.
You do, yeah.
Yeah.
And like this tube here, this tube is single butted, meaning it's thick at the bottom and then it gets thinner as you go up, and then it's a constant thickness. And they do that because that's the tube that your seat post has to fit into. So they don't want to butt the tube at the top because depending on where you cut it, it's not going to fit in right. So they just make it thin all the way up to the top. And what we have to look at when somebody comes in is, you know, do they pedal hard? And this is one of the things that we interview you. Or are you a spinner, which means low pressure but you pedal faster. If you pedal lighter, faster, then we will cut more off of the thick end of the tube because you don't need strength down here, and it's better
Alright.
to save a few grams of weight.
Got it.
As opposed to, you know, if you're a big guy and you mash the pedals and really like push down on them, then we would not cut anything off this end and cut off
More
the
off
thin end.
this end.
Yeah, because there's more than enough to get your seat post in. I mean, this tube is thin,
Right.
probably down to about here. So plenty of room there. So it's just that's the kind of stuff we consider in designing a custom bike.
Yeah.
And then it's, you know, the angles between the bikes, or, you know, between the various tubes. And so what we like to do is break the bike, basically cut it in half. And the angle of the seat tube determines how you sit on the bike. And the angle of the head tube and the offset of the fork determines how it steers. So we kind of put the two halves together, and then there's about 5,000 other minor variables that we consider.
Minor. Yeah.
But that's what's so cool about it. It's like you could sit here and every one is different. Every one is, at least for me, a piece of art, and our customers. I mean, a lot of people hang these things up in their houses. You know,
Yeah.
they ride it, they clean it up, and it gets hung in the living room.
Right.
Yeah.
Well, and then you
not?
had some at our museum, and they're beautiful to look at.
They
so
are.
why not?
Yep, for sure. So there's a couple different ways that we construct bikes. This one is what's known as lugged construction. And a lug it's a fitting, and the tubes slide into the fitting, and then it all gets silver soldered together. And then Dennis, who's my cleanup guy, goes in with little files and he spends a ridiculous amount of time and cleans everything up and tapers the edges and makes them look great.
Smoothing it out.
On a lugged frame, you miter the tubes up like these are. It's put together in the jig according to the blueprint, and you can see that the miters are like they're perfect everywhere. Like there's no gaps, nothing. That is uncommon. Most lugged frames, like if you get a production lugged bike, they don't give you great miters because once that's on there, you can't tell.
Can't tell.
Unless you ride it. And then these feel different. It's firmer, stronger, it's more accurate. The bike will steer the same to the left and the right because it has the same strength in both directions, as where if the miter is off a little bit, if the miter's hitting like up here but there's a gap over there, it'll be firmer this direction and softer that direction.
I'm also thinking if there's a little gap in the miter, even though you have the lug there, could it loosen everything up?
And it does.
And break the
Yeah,
solder.
if it's really an ill-fitting joint, what'll happen is the lug will develop a crack over time.
Okay.
Yeah, so that's what happens there. Another way that we build bikes is TIG welding. And TIG stands for tungsten inert gas. It's an electric welding process. And what happens is we have a torch, And the electrode in here is tungsten. And if you notice, there's 3 hoses here that come in. One of them is argon, which is an inert gas, which is the eye of the TIG. The gas comes up through the handle and comes out. And if you can see all that space in there around the electrode, that's where the gas comes out. So when you're welding, there's no oxygen or nitrogen that's getting trapped in your weld. Oxygen and nitrogen make the weld brittle.
Okay.
You want it to be pure metal. So what we do is we get welding wire that matches the alloy of our tubing. And when your miter is that tight, you hit the foot pedal, strike an arc, it heats up, and then you feed the weld wire, you move a little bit, feed it, move, and you dab it. TIG welding, when it's finished, looks like you got a stack of dimes and pushed them over. You have these like perfect little circles.
Oh, all right. Yeah.
Yeah. And getting back to the miter issue, if your miters are not tight, when you can certainly fill it with weld wire, but the problem is where you have that gap, weld wire goes in molten, hot. And when it contracts, or when it cools, it contracts. And when it contracts, it'll twist your frame. So then the frame has to go into our alignment table, and it has to be excessively straightened. As where when you have really tight miters, the amount of alignment you do is minimal, if at all.
Wow. Okay.
So it makes, if you spend the time with tight miters, it makes an all-around better bike.
Right.
So getting back to miters, let's look at how we do that.
All right.
So this is where we miter tubing. This is it's a Bridgeport milling machine. It's hands down the most versatile machine that has ever been built. You can machine pretty much anything. Every angle changes, every height, every dimension. And for mitering tubes, it works out because there's an infinite possibilities of how to miter tubing on this thing. So the way this is set up now, so this is a tube in a bike, and I've already set the angle, and we're going to put a miter at the second end. But before we do that, I'm going to talk about, when you look at the blueprint, we have a dimension. So let's say this tube has to be 550 millimeters measured from the center to the center. Well, who has a good enough eye to put a ruler against the tube and say, yeah, that's the center there, and that's kind of the center there, and then, if the tubes don't run parallel, then you have to determine what's the center of this tube, and so it's really tricky to get that figured out. So what we did was we designed this system, and all these parts here are used for setting up the machine for mitering tubes. So the way it works is, so let's say the tube you're mitering is 1.25 inches in diameter. So that's 31.7 millimeters.
Okay.
So you pull that block out. And let's say you're mitering up against a tube that's 38 millimeters. So you pull that one out. So you put the 38, before you put the 38, you put your first miter in the tube. So you set this angle, you put the proper diameter cutter in, and then this tube is clamped in here. This one would have been this way, and it feeds into the cutter, and it gets mitered. Well, putting the first miter is pretty easy to do. The problem is putting in the second miter so that it is exactly parallel to the first miter, or in some cases it has to be perpendicular. So this miter runs that way, but the miter at this end runs that way. So we came up with this system. It's all precision ground steel. It's all calibrated, it works nicely. So you put the first miter in. You put the diameter tube that the miter gets butted up against here. And then we have a system of rods. So you put the tube diameter that you're mitering in here. And I'm not going to set this up because it takes a tremendous amount of time, but 550 millimeters. So I pull a bar that's 400 millimeters from the end to the center of that hole. I pull all these other pieces, and what happens is this gets put into the milling machine in place of a cutter. This fits in here, drop the pin in it. Now, regardless of what angle you're mitering, the distance from the center of that cutter to the end here is exactly 400. Doesn't change. As you change the angle, it still stays at 400 mils. At this end, we put this piece in. And this also pivots so that you can change angle.
Okay.
But from the center of this to the end is 100 millimeters.
500.
So there, you're already at 500. So you put this in here, and if you can imagine this bar going through the center of that piece, and if you had a bigger diameter tube, this would be further apart, and the center would be moved over some, which would then change the length. So you'd have to take that into account. But this would fit through here. You slide this on to line up and hold the two halves in alignment. And then you slide the table back and forth until the gap here is 50 millimeters. So without using any judgment, like you don't have to eyeball it and say, well, that's kind of the center, so I'm going to measure from there to, no, this is exact. You can get this down to like the nth degree so that when the tubes are all mitered up and they go into jig, everything's perfect.
Perfect. Wow.
So,
And it's interesting because it seems pretty complicated, okay, and I'm sure it is, but you know, you start breaking it down to the different aspects of what you're trying to do, and it's like, oh, okay, makes sense.
it's like, how did the Egyptians build the pyramid?
Okay.
One block
One
at a
stone
time.
at a time, yeah.
Yeah, same deal.
You just kind of have to sit there and think it through.
Yeah, exactly.
Yeah.
You break down complicated tasks into like a simple process.
Yeah, digestible
Or
parts.
several
Right.
simple
Yeah.
processes.
And then you go through and do it. All right, so this one gets butted up against a 35 millimeter tube. So that sits here. And this one gets fit into the machine, and then with light pressure, we hold it against the plug. And just, you like to verify, so you just look around, make sure your miter is touching all the way around
tight.
on the plug, tighten it up. And now, Kendra, we were going to ask you to miter a tube.
Ooh,
So-
I've never done that before.
Okay, I don't know if you want to wear an apron, but I strongly suggest safety goggles.
Okay, yeah, definitely.
Dan, I don't know if you want goggles or glasses are fine.
Wear goggles, just in case.
Okay, I get an apron?
Oh, yeah.
All right. All right.
Okay, Kendra, so we're going to miter a tube.
All right.
So we got it all
Let's do it.
clamped in.
Okay.
So lift up on the switch on the box, nub all the way in the
Up.
back, the square box.
Uh-huh.
Just push up on it.
Reverse?
Yep.
Okay.
And then that lever,
Yeah.
you're going to push into the machine.
Okay.
Keep going. It'll click. All right, it'll stay there.
Okay.
All right, now automatically this tube is getting fed into the cutter.
Uh-huh.
And before I had a machine that had power feed, we used to crank it by hand. And the problem when you crank by hand is you do it by feel. And you always exert the same pressure, but that's not the best result. The best result where this moves in consistently.
Right, because you're human and you vary, your skin varies.
That's right.
Yeah.
And when you do that, those cutters shatter. Because all this tubing is thin wall, high strength, and if you move it too fast and the tube gets caught between two teeth of the cutter, they shatter. It has to be very consistently driven in. You're doing good work, Kendra.
I'm a pro at this.
Very good. So after the tube is mitered, we take all those burrs off so that it has like a nice, burr-free look to it. All right, you can just move that switch back to the
Middle?
Yep, middle spot. There we go. So that's a great looking miter. And all we have to do now is take all these burrs off.
Yeah. Clean
But-
it up a little.
But that's machined to fit up against an 1.25" tube, which you can now see fits.
Look at that.
So I would say if this museum thing doesn't work out for you, you have a future of mitering tubes.
Oh, it's my fallback.
Kind of long commute.
It is, but I'll make it work.
All the tubes are mitered. They have all these burrs on them. So we, by hand, will deburr them. We clamp it in the vise, and then the inside of the tube gets deburred with a round file. So we go all the way around. The outside, we use a flat file, and we just go like that. And you see the burrs are just rolling off.
Yeah.
And then when we're done, we'll get a little bit of emery and just make sure that everything in there is smooth, no surprises. After all the tubes are mitered, we then take them over to the jig table. We use the blueprint and we bolt down tube holders. Now, the tube holders we made in a bunch of different sizes, depending on what we're doing. So we have all these different diameters. And here's the other thing. I'm going to take a little segue for a second. Your finished product is only as good as the tools you have to make them.
Yeah.
So if you're a shop that has to buy everything from somewhere else, you don't play a big role in the design. And what we do is we have a lathe and milling machine that is not used for bicycle production, it's used for tooling. So we made all these fixtures here.
All these tube holders.
Yeah.
You made, wow.
Yep, well, set them up on a milling machine, they got bored through, milled up, and we do that for every tool that we need in the shop.
Well, then you know it's right.
Well, you do, but it also gives you control over the process, start to finish. So you don't have to compromise because your tools are anything less than what you want.
Right.
So like little fittings that get welded on, well, we make pieces that hold them. You know, some places use like a spring clip, pliers,
Sure.
and then you just like eyeball it, clip it down, and they're ready to go. No, it doesn't work that way. We make something that holds it exactly where it needs to be. It's straight, it's where it's perfect.
Wow.
So we make all those pieces here. Every piece of tooling. Getting back to the frame building. So all these tube holders get bolted down according to our blueprint. You know, we put protractors, measure the angles. The miters dictate the angles also. They also dictate center to center lengths when we set up. But when we're done, it has kind of like this configuration. Now, parts of the process have to get welded in before the frame is finished. It just makes the process easier. So for example, the rear dropout, we braze into the tube ahead of time. And after brazing, it kind of looks like that. Not terrible, but not great. And then Dennis, our finish guy, goes in and makes it look like that, which is perfect. He takes off every speck that just doesn't need to be there. And in so doing, he removes extra metal back in through here. There's forging marks in here. He takes those out, and when he's done, it's perfect. I mean, like I said, it's a piece of jewelry. So these are made as a sub-assembly, braze in the dropouts. This particular frame gets what's known as a wishbone seat stay arrangement. So it's two pieces of tubing here, one piece that runs front to back. There's a center piece that's the rear brake bolts into, and we actually machine that up here because we want it a certain way. And then this cap is also another piece of tubing. We get a hole saw and we cut through a piece of tube until we get the diameter that we need to fit over this tube. And then it all gets welded together. So this gets made as a sub-assembly. Dennis will then clean all this up. And when he's done, and this gets painted, you cannot tell that this is 5 different pieces of material. It'll look like one.
One piece.
But this fits in. There we go. Fits in like that, and then this all gets brazed in. And then the same deal. This fillet brazing gets done here. It gets smoothed out. When it's painted, this will look like it was molded.
Wow.
Yeah, a lot of handwork.
Oh yeah.
But mediocrity you can get anywhere.
Yeah.
So that's why we do what we do. We get people that they travel from everywhere to get high-end bikes. So now that everything is set up on the jig and the angles and lengths are what we want, the frame can be welded. So we could either put the lugs on it and braze it with a torch, or we can TIG weld it. And to show you how brazing gets done, I have a fork that's set up in a jig over here. So what we have here is a fork. The crown is already brazed onto the steering tube. The dropouts are brazed into the tube. They're all cleaned up already. So now we're going to attach the blades into the crown. To do that, you have to clean the inside of the sockets, get it down to nice, clean, bright metal. We dress the edges to make sure that they're crisp and straight all the way around. The tubes, they get sanded, clean metal, and then we paint this white flux on there. And what the flux does is it gets the metal absolutely clean. It like attaches to the metal and any contaminants get floated out. So a lot of times when you're done brazing, you can see like an outline of black at the edge of the flux where it floated out, whatever dirt was still in there. So everything, like we're big on getting everything really clean when we braze. When we mix our flux from powder, I use distilled water because I don't want to contaminate it with whatever I'm drinking. And then the welding wire I polish to take whatever oxides are on it off. So let's do a little brazing. So I get a nice reducing flame. The inner blue cone here is kind of blunt and rounded. An oxidizing flame, that would be like to a pencil point. Mm-hmm. Oxidizing flames will burn your flux out. So you use a reducing flame. And you don't heat any one area up because your flux is going to run all over the place. So you kind of do it in stages. And one thing about building bikes, you have to be a contortionist because you can't move the part to the position you want. So you have to move.
Do it yourself.
Yeah, and then you always have to lean over to get the right vantage point. So you're literally a contortionist. So the idea is you want that flux that was creamy white to right there. You can see how it's clear. And when it is, you can melt your silver. And I'm real big on off and on with the flame. And you can see how the silver has, it just popped in. And you can see like right there's a puddle. And that I could literally work in like that until it goes away. Silver will always follow your heat. So if you notice, I'm heating a thick part of the crown here, and then when I melt the silver, hopefully that's where it goes. Like it's on this side. That looks pretty good. Let me work on this side for a minute. So I'm making this look easy, but I have a tremendous amount of time behind the torch. One of the tubes that we work with is made in England. And it's really lightweight and thin, and it has a real heavy heat treatment. So they literally want you to build a sample bike, send it to England, and get it tested before they'll sell you more tubing to actually build bikes. So you have to get certified. So we're, actually me and Dennis are both certified. So we're going to braze the other side of the fork now. If this were a factory setting, as soon as we were done brazing, we would pull this out and set the next one up and go. Well, we don't do production here. Everything is one at a time, and what we build are perfect bikes. So we will leave this fork in the fixture until it is absolutely cooled off. That way, It doesn't change in terms of alignment.
I was going to say, if you were doing a lot and you moved that out of there too soon,
It cools
because you
unevenly.
need to do another one so quickly, yeah, wouldn't that could potentially shift it a little bit?
And it
right?
does.
Yeah.
Yep. Yeah, we took a contract with Raleigh, which is an English bike company, and this heat-treated tubing, they needed 1,300 forks built. And it's a difficult contract to fill because you need somebody that can do production, but that material doesn't lend itself well to production.
Huh.
So worldwide, there might be 3 or 4 people that could have done that job for them.
Oh, wow.
So for an English company, they ended up here in media, and we actually did it. We had 3 years contract doing those.
I was gonna ask how you did it, but that 3 years makes sense.
No. We did 1,300 each year for 3 years.
Oh,
Wow.
Yes. All right. So what I'm doing here is every time I touch the rod, it leaves a little mark. So I'm getting those marks to flow out, making sure everything is even all the way around. So that's done. So now that that's done brazing, I'll leave it in there until it cools off.
and how long would that be?
Like about 10 minutes.
Okay. I was thinking,
A day.
well,
No.
I was thinking a couple hours, I don't know.
Now, you know what it is? All the tubing is thin, the fork crown is thin. It doesn't absorb a lot of heat like
Got it.
like an engine block that
Right.
stays hot for hours and
Yeah,
hours and
yeah.
hours.
Yeah.
Like, there's not a whole lot of material there. Even though it's hot, it doesn't stay hot
Right.
for long.
Makes sense. Looks like you did a good job.
Kendra, can you hand me that frame?
Yeah.
Thank you. So after the frames are welded or brazed, what we do is we put them in an alignment table. Not so much to see if it's out of alignment, but to verify that it is straight. So the way this works is we clamp the frame against a very flat surface. There's a bar that goes between the seat and this holding block. And before we put that on, what we do is we use something like this. And this V gets centered on the tube. So you can see that it's touching there, but there's a gap on the bottom. So we would slide this up like that. We now have our reference set for this. And then we use a gauge, and we would measure the height here versus the height at this end.
Okay.
And then this steel bar fits into the frame, and you can tweak it up or down to get it level. Once it's level, we put the steel bar and that all gets tightened down, and that's tight. So now when we go to straighten the next part of the frame, we're not moving this because it's already it's in
Straightened
line.
that.
Yeah, it's already
Like
straight.
your guide.
Yes, exactly. So then what we'll do is we'll bring our gauge back. These two tubes are the same diameter, so I could use the same height from this gauge, and we would measure this end versus this end. If it's off, we would adjust it up or down. Once that's set, we put a support underneath it to hold it so it doesn't move. Then we have another bar system that fits in. And part of what that block does is it prevents the frame from sagging, because this bar is pretty heavy. I mean, it probably weighs 10 pounds. So that gets tightened in, and then there's reference points here, so we would set the height to match up against that, and then compare it to the same one on this side, and then that'll tell us if this tube is skewed
Got it.
relative to that tube. Verify that everything is straight, then we can take this bar out. And then this gauge that we already set up so that the center of this V lines with the center of the tube. What that guarantees us now is that the tip here and this tip are equally distant from the center of that V.
Okay.
So we would set the height of that, or the width, to the same as what the frame needs to be when it's finished. Most bikes, road bikes, that's 130 millimeters. So we would put a caliper here, measure to 130, and then slide that into here. And then you can compare those two tips. Now this frame's, I'm not exactly sure what it's set to, but so you put that in, and you can see this one, it's off just a hair. That pointer's touching, and there's a little gap up here. So then we would cold set this, bend it just a little bit so that it touches each point, and it's exactly 130. Once that's done, we slide this out of the way, and we have these pieces. And what these do is they get bolted into the dropouts. There's an upper and a lower. And what these do is they assure that the dropouts are parallel.
All right.
Like these are really close. The two cones are the same, like all the way around. But I'll put this in crooked so you could see. So if they were like that, for example, then you would have to twist this one up and twist this one that way. And then that would move the two cones, like instead of being like that, it would move them like this.
Right.
And it's important that the dropouts are parallel, because when you put the wheel into the finished bike, when you lock down the axle, if these are not parallel, they're going to bend your axle. And that puts a load on the bearing.
Okay, I have a question, is when you are tweaking this and bending this or making these parallel, does that weaken anything on this end of the joint?
Well, in theory, yes, because when things get bent, you have to take them past their yield strength. So yeah, that's why it's important that we have accurate miters so that we don't have to cold set.
Okay.
Right. You want to adjust as little as possible over here
Yes.
Yeah.
So we do the most work
before you
mitering.
even get here.
Yes. And even when we weld, we have a sequence that we go through. Because if you do all the welding on one side of the tube, when that weld cools, it'll pull towards the weld.
Yeah.
Right.
So we weld a little bit up here, and then we'll weld a little bit on this side, and then we'll weld here, and then we'll weld here. So we don't just go like around the tube and call it done.
Right. Okay.
If you did that, everything would be crooked.
Yeah.
Yeah, so we have a sequence. After the pieces are brazed, they go over to Dennis, who is our cleanup guy. He's been doing cleanup for me for 6 years?
It's close enough.
36
Wow.
years so far. So what happens here is the forged dropout, which is what holds the rear axle, is brazed into a chainstay. And that's what the braze looks like. Not ugly, but not what we want. And then Dennis will remove everything that doesn't look like a bike and make it look beautiful. And that's where he is. When we build a custom bike, it gets somewhere between 40 and 60 hours of handwork. We are just meticulous about metalwork. Dennis, like I said, will remove everything that doesn't belong there. Most of it's done by hand with files. We have, I don't know, maybe 100 different shapes of files and little rifflers that, like little watchmakers files we use.
Wow.
They're all made in Switzerland. They're really hard to get, but we got a bunch of them. And we'll go in, and they're great for hitting areas that you can't normally hit with like a big flat file.
So I'm doing the same here.
You'll see little divots here. Those will get refilled back in, and so it's a process of just making sure that everything is exactly the same. So when you see it, you can actually feel that there. You do not feel any difference if you run across
it's like
there.
one piece.
It's one molded piece.
Yeah, there's no transition from one part to the
So
next.
that's what it looks like before, and then after, and then Harry has a piece here that's
Yeah, so
really after.
Yeah, so this is the dropout that Dennis already finished up.
Wow.
So it went from what that used to be to like that. It's like, it's perfect. Everything blends in.
Yeah.
Everything is smooth.
Wow.
So after we're done with the finish work, then we have to do the paint work. So Dan, can you hand me the frame?
Yeah.
Thanks. So this is a good representation of what they look like when painted. This is a two-tone pearlescent paint. It's taped off between the colors. This is a base coat, clear coat paint, meaning we shoot just color, there's no gloss to it. And then when all the decals are put on, the clear coat is what gives it the durability. And the reason we do that is base coat goes on really thin. An average paint job on a bike is between 4 and 6 ounces. And when people get excited about drilling holes in components to save weight, all of a sudden a 4 to 6 ounce paint job has value. So by going with a base coat, clear coat system, the millage, which is the thickness of the paint, is much less, so it's lighter. So a base coat, clear coat system might come in at 3 ounces.
Gotta save an ounce.
It's only an ounce, but an ounce here, 2 ounces there, and
Adds up.
it adds up. Right. So when we build bikes for the Olympics, because it takes us so long to get a bike built, between the machining, the finish work, the paint, for those people, they buy one bike, but we build 2, and we keep the second one.
Okay.
And if they damage the bike and need a replacement quickly, we have it. And if they don't need it, we have them to sell, which is this one. So this one was a track bike. Rear dropouts face backwards. There's no gears, no brakes. It's aerodynamic tubing, so it's teardrop shaped, so there's less drag as it goes through the air. In order to get the weight distribution proper, we do a cutout on the seat tube that allows the rear wheel to come forward to where it needs to be. And the way we do this cutout is we actually made a fixture that it's like a belt sander that fits inside the frame, and it literally skims like this.
Wow.
And then we feed the frame in a couple thousandths of an inch, do another pass, feed it, do a pass, until we grind out that shape into the tube. And then we get a piece of sheet metal, lay it in there, we trace out the shape, we trim the metal down to this size. It gets TIG welded all the way across. And this seam, I mean, when you look at it, it's perfect.
Yeah.
But when that was put on, it looked like these welds up here.
You had your finishing crew on it.
That's right. Dennis, and that's what he's
That's
great
amazing.
at. He makes things look perfect.
I also noticed these little indents right here and here. for the
Yeah.
tire. Yeah.
Right, so what happens on this one, because of the way this frame is constructed, we brought these 2 tubes in really close to make it more aerodynamic this way, except when the bike wheel is all the way forward, the tire hits. So we had to put little dings to give you some clearance.
Ding. Technical word, right?
Very, very technical.
Yes. All right, so we saw all the kind of lead up to, but now the big question is, do you have any final product here? We can see the before and after now.
We do, yeah, let's go upstairs.
All right.
So there's a good representation of a finished product. That wishbone that we saw earlier, that was multiple 5 pieces braced together.
Yeah.
So when that's done, it's going to look kind of like this, where you can't
Okay.
really distinguish between components. Like it looks one piece molded.
Wow.
Yeah.
That's incredible.
Yeah, and it's interesting because people look at this and they look at this black pinstripe and you go, wow, how did you get a pinstripe that long, that perfect? And it was easy. The whole bike was painted black first.
Okay.
And then they put fine line tape.
Ah.
And then they masked up each side of it
Right.
to paint the colors, peeled the fine line.
Leave the stripe.
And you have this perfect black stripe. See, there's a trick to everything in life. You know the trick, you know life.
Wow.
So this is a pretty good representation of, you know, how well the miters fit together, fancy cut lugs, the way the paint is all finished. It's just, you know, it's a package. It looks great.
Yeah, these lugs are really, they catch my eye, and especially how they're painted different. You can see all the
Yeah, I mean, like in here versus
the
yeah.
detail work in them.
Yeah. So it used to be, if you went back to like the 50s and the 60s and even the 70s, bikes were, like, people were proud of their bikes and they wanted them to be like beautiful, and lugs fit into that because you could sculpt them and you could make whatever shape you wanted, you could paint them any way you want. And today, like, things are kind of generic. Like, you put a weld down, or if you buy a carbon fiber bike that's molded, like, your bike is the same as 5,000 other bikes out there. And during the golden age of cycling, that wasn't the case.
Wow.
You know, you had all this individuality.
All right, so we wrapped up our tour. We're holding this beautiful frame, which has all this detail work. This is really gorgeous. It's light.
It is.
So light.
Yep.
This was great. I know we had Harry. We had talked to Harry before about, you know, what he does here, but seeing it was really
It was, yeah.
a lot more helpful to understand exactly what all goes into making a frame like this. And we hope that you at home felt the same way after watching that. So.
Yeah, I have learned a lot here.
Yeah.
And you know, just understanding the amount of work that goes into these. Every little piece, you know, fitting things together and finishing them, and you know, and not just the amount of work, but why it's done too. And that I like.
Yeah. Yeah, I know I know you before have talked about racing, and then there's with cars, and there's the same idea. Why do you build the car this certain way, and we got that here today in bike form.
And with the racing, you know, I follow auto racing pretty closely as a fan, and you know, I like the technical end of it, and a lot of this transfers over. Same thing. Obviously, it's a lot less horsepower, but the same way as far as the construction and balance and all that. I really enjoy that.
Yeah. So like I said at the beginning, you know, make sure you go back and look at our YouTube playlist, because we have another video with Harry talking a little bit more about the history and how he got into this, and some of the you know, moments in history he got to participate in because of his bicycle building. So today was the kind of in-depth technical
Factory tour.
Yes, the factory tour. So if you want more background, go back and check that video out. And we're really thankful to Harry and Cycle Sport, and everybody here has been so nice and helpful, and showing us around and welcoming us. If you are interested in the retail end of Cycle Sport, this is a great shop. Please come visit them in Media, Pennsylvania. And yeah, we've been to a great place today.
We have.
So join us again next time. Thank you, everyone.